We're going to the Campton talk.
And that allows us to run both pods even if one engine room is out of service. We can still run them on what we call a hedge motor, still make about 13, 14 knots that way, so that's pretty good.
So that's just like a smaller map of everything down there, right? That's
yes,
like
this is the, for the engine room, this gives me immediately an idea of what's going on there. So, and then we got all kinds of gauges here to figure out what's going on. That's pretty much that. And a lot of buttons.
Any of them cruise control?
Yeah, actually they are. Let me go back. So, okay, so the buttons here. So this, normally when the engineers start the pods, they have to give control to the bridge. So we do that with these 4 buttons, and we can switch between the different modes of control with these 4 buttons. So when we're sailing normally, so right now we are in what's called open sea. When we get close to Victoria, we switch to maneuver direct, and all that does is change the way the engines react. They get a little bit feistier. It's like switching your car to sports mode. This is the maneuver mode. So this button activates these 2 handles, and then on the left this is the joystick. I'll show you a picture of that later on. We can actually combine the engines and the bow thrusters in one control. It's called our joystick. So back to the other one. So all of that, what we just showed you, was in the middle of the ship. We have the same controls on each of the bridge wings, so we can, when we come into dock, then we can see over the side what's going on. So actually, so this button is the steering wheel. So they didn't even give us a whole steering wheel there, just a little button. Controls of the engines, bow thrusters, and then over here is the joystick. And this is a radar repeater and a microphone.
Yeah, so all the same as in the middle, just on the wing for you right there.
You got it.
All right.
Pretty soon you'll be riding. So joystick. It's not exactly one handle. You got again. It's a point and shoot system. So you point this handle the way you want the ship to go, and then push it how fast you want to go, and the ship will move at either ahead or sideways or 45-degree angle, and it will maintain that heading or that angle if you want to. With this you can rotate the ship, and with this you can increase or decrease the speed with which that all happens. We can actually set, right now the turning point is in the center, we can set the turning point forward or aft, and it will adjust the control, so actually the stern will stay completely stopped and the whole ship turns around that. Now this is the best button on the ship. This is called the DP mode system. If I press that button, the ship stays exactly in that spot, with maybe 10 inches left or right, or forward or backwards. That's a very good button to have. You have a question? I see you thinking.
No, it says call cruise. Is that for me? Or is that your cruise control button down there?
No, we have another button that says call Saul.
Call Saul.
All right, so this is the business end. This is the ASA pods. This is actually not our pods. I believe these are the Westerdams, but ours kind of look the same. So you see they're pretty big. They at slow speed they actually do act like a rudder, but so the electromotor is inside here. You can go down there. There's an inspection edge, and you can climb down and go either in the front or climb all the way to the back of the pod. And I've been there. It's a little narrow, so I don't go there again unless they grease me up real good. So the propeller is actually a fixed propeller. So the only way we change speeds is by changing the revolutions of the pod. Yes, maybe. Okay, this is an action shot. Now these are our pods, and the difference you can see is these fins that they put on the back end of the pod. they actually increase our fuel economy by about 5% by doing that. Initially they had made them a little bit too long, and the result of that was that they hit each other. So it was not a good day. Luckily we found it out before we left the dry dock. So at this point the bolts are actually only maybe 3 inches apart. So you see how fast they can turn around really. Okay, so this is the stabilizer. Keeps the ship upright, sticks out about 20 feet. They fold into the hull if we don't need them, and they're about 6 feet wide or so. So when the ship rolls one way, there's a little gyroscope that says, okay, the ship is rolling, do something, and then the fin tilts up or down to create a lifting moment that puts the ship back upright. So it's just like a little airplane wing.
Just to the side, but no corkscrew and no back and forth, right? Is that right? They only do the side?
Yeah, only side to side, and they have, there's different systems out there, but for big ships this is the most effective. They have tried it with 2 sets of stabilizers to see if they could control the pitching motion, but that doesn't work. There's just too much power involved. Bow thrusters, well, I put a nice circle here to show how big they are. The thruster tunnels are about 7 feet in diameter, so you can actually stand up straight and work on them. With 3 bow thrusters, 2,500 horsepower each. 2 of them are pointed this way and 1 is pointed that way, and that is because the flow over the propeller is not exactly the same thing, so it pushes harder going forward than it goes backwards. So by alternating them, they kind of took care of that problem. We got the anchors here. It's about 9 tons of steel hanging here, and we have about almost 1,000 feet of chain to anchor the ship if we should need to do that. So there's actually 2 of those, of course. There's 1 hanging here, 1 hanging here, and actually we have a spare anchor on the bow as well, in case we lose this one. Okay, this is to the electronic navigation system. So what you're looking at is the electronic chart. So we actually don't have any paper charts on board anymore. Everything is electronic. The red line is what the navigator has programmed in for our course. So that's what the automatic pilot follows. This is actually a picture of Half Moon Cay, and so it shows the bottom and everything that is associated with that. Other information, exciting stuff there. This is a radar picture. So maybe from the movies you're familiar with a picture with some yellow dots and some green dots and stuff like that on it. So think about the screen without all the blue stuff and the red stuff. You get the same thing. So this is a radar, but it has a chart underlay. The big advantage of that is that the radar sees everything that is above the water. But with the chart underlay, we can actually see everything that's underwater as well. So there's some kind of underwater hazards. We can see that and plan for that. So that's why that is. And we get like a wind meter on here and a current meter and all kinds of other information for the navigator. This picture is. So here on the bottom we got our echo sounders. We actually have 4 of them, forward, back, and then port and starboard side. GPS, we have 2 main GPSs, but actually probably about 8 or 9 GPSs on the bridge for different pieces of equipment. These are 12-channel receivers. In comparison, your cell phone probably has 2 or 3 receivers to get your position for the map and all of that stuff. So they're a little bit more accurate to work with. This is actually why I took this picture. This is our, as you can imagine, fuel consumption is very important. And we have what's called a dynamic trimmer system. The way the ship lays in the water and moves through the water very much affects how much fuel we use. And so we have a little screen that tells us exactly what would be the optimum way to do that. So you see, right now it says actually that we have to trim a little bit more by the stern, 17 centimeters by the stern, so we can take some ballast out or move it around to make that happen while we move through the water. It also, we put in the route and it actually calculates what would be the optimum engine setting, how many RPMs we have to run to get to the next destination exactly on time. So very, very nice machine. Safety part. So this is a picture of the Mimic control for all the fire screen doors. The watertight doors are actually here on the left, and each light represents a door or a fire detection zone or something like that. On the right you see a couple of computers. That is basically the same as what's on here, but if the computer fails, we can operate everything from the Mimic panel. In the old days we had one switch, actually we still have one switch to close everything. Nowadays with the computer we can actually target our response to any incidents to just the space that we want. So say a fire detector would go off in this space, then we can close the door, shut down the ventilation, everything in this area alone. So we don't affect any part of the ship other than this part. And that makes it much easier for the response teams. You can imagine if the whole stairwell, all the doors are closed, and they have to open each individual door and work their way to the show lounge. That'd be very hard. If they can just march straight up to the entrance and get in here, that saves a lot of time in the emergency response. Here's the ship again, from the air. And we're going, so that probably means whoever's in this helicopter missed the ship. Coming by. Engine room. Mentioned we have 6 engines, 4 12s and 2 straight. So this is a straight 8 engine. The V12s are V engines, so 6 cylinders in each bank. So this is the bottom. This is the crankcase. If you open one of these doors, you can actually see the crankshaft going around. They never do that when we're actually running.
Yeah.
So
I wouldn't attempt it.
that would not be good.
It's just the size, but it's